Before we begin today, I wanted to take a moment and go over the homework assignment on Bohr diagrams. So if you look behind me, I have went ahead and wrote out the electron configuration for these 12 examples. Now, if you look, we're going to pay close attention to these large numbers out front that tell us what energy level these electrons are in. So in the case of manganese, I have a 1, I have a 2, which is in 2 different locations, and I have a 3 that appears in 3 different spots, and I have a 4. What we're going to do is we're going to take everything that's associated with a 1 and group it together. Well, in this case, there is only one thing. So 2 electrons in the first energy level. In the second energy level, we're looking at anything that has a 2 in front of it. So a 2 plus a 6 means in the second energy level, we have a total of 8 electrons. So in the second energy level, I can go ahead and write 8. In the third energy level, now I have to track down everything that has a 3 in front. So I have 2 here plus 6 more. I'm going to skip over this. I'm going to go here to the 3d5. So I have a total of 2 plus 6 plus 5, or 13 electrons in the third energy level. And then in the fourth energy level, I have just one thing, the 4s2. So I have a total of 2 electrons there. When I look at my second example, arsenic, I have 2 electrons in the first, I have 8 electrons in the second. In the third energy level, I have 2 plus 6 plus 10, or 18 electrons. In the fourth energy level, I have 2 here plus another 3, so a total of 5. I'm going to go ahead and finish off all of these, and then I'll pause this, or I'll leave this open so that you can check your work. So what I would like to do now is to talk about the most likely charge. This is actually where most students had the greatest difficulty in answering this homework. So I've created this page to help us figure out how many electrons are in the outermost level and what that most likely charge would be. So I wrote up here 2 kind of important facts. Number 1, most atoms, except elements with atomic numbers 1 through 5, are stable when they have 8 electrons in their outermost level. The second fact is that atoms are going to lose or gain electrons in order to get to that stable 8 electron configuration. So for atoms that have 1, 2, or 3 valence electrons, they're going to lose those electrons. So they will form either a positive 1, a positive 2, or a positive 3 charge. We'll take a look at an example of that. So if I look at calcium, calcium has 2 electrons in its outermost level. So these are going to be lost. Calcium will form a positive 2 charge. When these 2 electrons are lost, notice that I now have 8 electrons in my outermost level. Let's take a look at a second example. We look at cesium. Cesium has 1 valence electron. So if that 1 valence electron is lost, we wind up with a positive 1 charge. If I cover up that 1 electron, notice now that our outermost number is 8 again. Again, a very stable electron configuration when you end with 8 electrons. Let's go back and take a look at examples where we have 5, 6, or 7 valence electrons. So I wrote for atoms with 5, 6, or 7, these atoms will want to gain electrons instead of losing them. And as a result, they're going to take on negative charges. So an atom that has 5 valence electrons will need to gain 3. So it will get a negative 3 charge. An atom that has 6 valence electrons will need to gain 2, so it will wind up with a negative 2 charge. And an atom with 7 valence electrons will gain 1 and end up with a negative 1 charge. Right in the middle, you have atoms that have 4 valence electrons. And really, there's an option there. We can either gain electrons or we can lose electrons. If we gain electrons, we end up with a negative charge of -4. If we lose electrons, we wind up with a positive charge or +4. So let's go back and look at a few examples of these. So if I look at arsenic, arsenic has 5 valence electrons. So in order to get to 8, it is going to gain 3 electrons. When it gains 3 electrons in order to get to 8, it will take on a -3 charge because it has 3 extra electrons. If we look at something like iodine, which has 7 valence electrons, it's going to gain 1 electron to get to 8. So it will take on a -1 charge. I'm now going to fill out the charge for the rest of these atoms. You can now see that based on their number of valence electrons, we have identified the most likely charge. That doesn't mean that there can't be a different charge, but these are the ones that are most likely.